Hello, welcome to my new video where I will solve different equations from simpler to more complicated, trying to include as many topics as we can. Also, I will introduce you the algorithm that allows you to very quickly organize your equation and then solve it. And at the last step, you need to always check it. So first, let's start with the algorithm. It has 5 steps. It's very simple, very easy. You just need to know the order of operation and how to multiply, sum, subtract and divide numbers. First of all, we want to delete all parentheses. All parentheses are gone. We throw it out of the window. They are very often they are very useful in expressing different solutions. But here we want to be as simple as possible, so no parentheses. Second of all, we want to transfer. We want to pick a number and transfer to the right side. We want to take variables and take it to the left side because we want to find what variable means. So we want to have it on the left side, and on the right side we want to have only natural numbers, real numbers, fractions, any kind of number without the variable, without the x, without the y, without the z. First step. In the first step, we want to combine all variables. We want to combine x's together. We want to combine y's. You know, you get the idea. And fourth step, we want to reverse it. We want to multiply by the reversion of the number. So we want to divide it. So on the left side the variable will be in the more simple way. So the coefficient, the number beside the variable. So for example, when we have 4x, this is the coefficient. The 4 here is the coefficient and the x is our variable. So we want to divide by 4 or multiply by the reverse of this number, by 1 over 4. Reverse. Because as we already know, multiplying is dividing is the same as multiplying by a reverse of this number we have. And the fifth step, optional but extremely important, especially at the beginning when you are trying to solve different equations, when you are thinking that you have the right solution, you always need to check solution, because if you don't check the solution, you can very often find yourself in a pickle, because at the test the teacher will just give you a failing pass. But when you get the experience, when you get more advanced in this kind of math, you will go through it like a breeze. So remember, checking the solution. Every time you don't know if the solution is correct, check it out. Okay, let's start with a very simple solution. 4x plus 5 equals 2x plus 11. Okay, there are no parentheses in this equation. We want to transfer. So we transfer all the x's, all the variables to the left side. We also transfer the real numbers, the natural numbers, because those are natural numbers, to the right side. So we get 4x minus 2x equals 11 minus 5. Because every time we transfer numbers, remember the scale? On the scale needs to be balanced. So whenever we transfer from one place, we subtract it. Okay, so we get 2x, because now the third step, combining the variables. Here we are simplifying. We get 2x equals 6. Okay, so we have 2x equals 6. We now take the reverse of 2. So 1 over the original number. So 1 over 2. So we multiply by 1 over 2. We get x equals 3. We check the solution, very important. Okay, so we have 4 times 3, 12. 12 plus 5, 17. 17, okay, on the left side. And 2 times 3 equals 6. Plus 11, 17. 17 equals 17? Yes, it is equal. So we have a correct solution. X equals 3. Okay, so now we have the second example where we have the parentheses. So first of all, we eliminate all parentheses. So we multiply, because what we have here is a number. Imagine that x minus 1 is some kind of number, and we use the regime of separate properties, the commutative law, to multiply this number, the coefficient 2, times what is in this parenthesis. But we need to remember, very important stuff, that we multiply by 2, by x, and by minus 1. Okay, so we do it like this. 2x minus 2 plus, what we have? 3 times x, 3 times minus 2. Minus times plus, we have minus. So we have 3x minus 6 plus x equals 2x plus 4. Okay, so we have the simple. Now we go to the second part. On the second part, we take the 2x transferred and all the real numbers we transfer. So we have 2x plus 3x plus x. We have 5x, 6x. We have 6 minus 2x. 2x. We get minus 2 minus 6 to the right side. So we have plus 2 plus 6 plus 8 plus 4, 12. Then we subtract, we have 4x equals 12. The reverse of 4, the coefficient here is 1 over 4. So we get that 4 equals, x equals 3. Because when we multiply 12 times 1, it's the same as dividing by 4. Because as you see, 12 times 1, 12 over 4, 12 over 4, 3. So x equals 3. Let's check it out. 2 times x minus 1, so 3 minus 1 equals here 2. So we get 2 times 2, 4. 4 plus 3 times x minus 2, so we get 1 here. 3 times 1 equals 3. Plus 3 equals 2 times x. 2 times x, we have 6. 6 plus 4, 10. 4 plus 3, 10 equals 10. So the correct solution, going by the algorithm, very simple, very easy. Whenever you don't understand something, you need to stop the video and try to expand this, try to check out my way of thinking, and try to think in your own way, because for every person there's a different type of solution. Maybe you want to shorten it even more, maybe you want to expand it to see every process that is being made, but it's very important to find your own way to solve equations. And now we have fractions. A lot of people hate fractions, but they're very simple, because in fractions, in equations with fractions, what we first do is multiply by a common number. What we have? We have over 2, over 3, okay, and we have over 6. If you see it, 2 times 3 equals 6, so we have a common denominator. In the next lesson, I will explain about least common multiplier and greatest common divider. Those are very important Euclidean algorithms that show you a way of quickly solving expressions with fractions inside of them. So we first multiply the entire expression by 6 to eliminate all fractions, because fractions are very cumbersome, and also it's very easy to misinterpret them, to solve wrongly, to find a wrong solution. Okay, we multiply by 6. Okay, so we have 2, 6 times 3, we get 11x, 11 by 2, x, plus 6 times 1 over 3, we have 6 over 3, we have 6 times 5 over 6, no? Very easy, 5x, because here is 5 over 6 times x, plus 2. 2 times 6, 12. Okay. And as you see, here we now divide. 18 over 2, we get 9x, plus 6 over 3, it's 2, we get 5x, we get plus 12. Okay, so now we have the second step. We are transferring to the left, transferring to the right, and we get 4x, 6x minus 5x, and we get 12 minus 2. So 4x equals how much? Minus 2, we get 10. We multiply by the reverse of this number, and we get that x equals 2.5. So we get that x equals 2.5. Okay, we can check it out, but very important stuff, when you check out the fractions, it's very easy to substitute, multiply, and then find out that the solution is wrong. But it doesn't mean that it is wrong, but sometimes you just multiplied wrongly, multiplied by wrong denominator, and you find out that, oh, my solution is wrong, but it's not wrong, it's correct, but you misinterpreted one of the multiplying signs. So what do you do? First of all, you check out not the first original, but the third one here, because as you hear, what we did here is simplify the expressions, and we can substitute to these equations to check it out, because we multiplied by 6 here. Here we just did the dividing part, and we have here 9x. Okay, so 9x times 2.5. 2.5, it will be about 18 plus 4.5, so you will have about 22.5. 22.5 plus 2, 24.5. We have here 5x, so we have 5 times 2, 10. 5 times 1 over 2, we get 2 over half. So we get 12.5 plus 12, 24.5. So it's correct. Whenever I try to visualize the fractions, I always imagine a pie, an apple, or maybe more abstract, the grains of sand on a single beach, or maybe even different parts of. Try to take your favorite thing from cooking, from game, and try to imagine it as a fractions. For example, the fraction that this particular gun takes over this map of terrain that you are on. Okay, and the last thing that I want to introduce is sometimes you get an equation, of course more complicated than that, where there is no solution, because here x equals x plus 1, and we get x minus x equals 1. Here we get that 0 equals 1, but it's not correct. If something wants to be equal to, it means that it's the same. 0 is not the same as 1, the same as I have this hand here, and if I didn't have this hand here, I would have one hand, here 0 hands, so it would be not equal to itself. So here we say that there are no solutions. It means that there are no x's that check these expressions out.